Section 2.6, variation. Okay, all right, here we go. So this is basically a type of application problem that you could see, okay? And if you focus on the keywords, it's actually pretty simple to do, okay? So here's some words that we want to watch for, okay? The word directly, or direct, or directly, specifically talking about direct variation. That's your clue to use the little formula y equals k times x, okay, where k is a constant. K is a constant. Okay, it's also called the variation constant. So I'm gonna write that variation constant. Okay, so direct means you're directly multiplying k times x. Okay, so here's an example. You're given a sentence, a statement that says, find the equation of variation for the given situation. Y varies directly, there's your keyword right there, directly as x. That's your indication to use this equation here. And y equals 0.1 when x equals 0.2. Okay, so there's a lot of information there. First of all, again, y varies directly as x means, okay, I'm going to start off with y equals k times x. Now, I have to find k. I have to find k. Well, use the information they give you. When y is 0.1, x is 0.2. That's an equation that we can solve. That's 0.1 equals 0.2k. If I divide both sides by 0.2, I get k. It's going to be 1/2 or 0.5. So the equation that I'm looking for, y equals 0.5 times x. I almost made the mistake, right? The most common mistake I see is people write this as their answer, right? Nope, 0.5 is k. So 0.5 times x. All right, let's do another one. Example 2. Find the equation of variation given the situation. Y varies directly as x. And there's that key term again. And y equals 3 when x equals 33. Y varies directly as x. Okay, I know I have to use that formula. Plug in what I know. When y is 3, x is 33. That gives me the equation 3 equals 33k. If I divide both sides by 33, I can reduce that. That's 1 over 11. So k is 1 over 11. Plugging it back in for k in the equation gives me y equals 1 over 11x. Pretty simple, right? You're solving a pretty simple equation. All right, let's move on. So that's one type of variation. There's really just two types. That's direct variation. Now we have inverse. Inverse variation. Very similar. If you see inverse, think about k inverted. In other words, well, not really k inverted, but think about k. Let me write out the equation. I can't think of the words. Y equals k over x. Okay, so the x is what's being inverted. In other words, you're dividing a constant k, the variation constant k, by x. So directly, you directly multiply, where are we? There we go. You directly multiply k times x. Inversely, you divide k divided by x. Okay, let's see. Example 3. Find the equation of variation. Given the situation, y varies inversely as x. There's my key, my clue to use y equals k over x. And y equals 12 when x equals 5. Okay, plug it in. 12 equals, don't know what k is, when x is 5. To get k by itself, multiply both sides by 5. 12 times 5 is 60. Okay, so 60k. 60 equals k. So replace k with 60, and I have the equation of variation. Y equals 60. Oh my goodness, 60 over x. By the way, you can always check it out. You can test it real quick, right? If I plugged in 5 for x, 60 over 5 would be 12, right? Y equals 12. Okay, so you can check it. All right, let's do another. Example 4. Find the equation of variation that for the given situation. Y varies inversely as x. Okay. And y equals 0.1 when x equals 0.5. Inversely, y varies inversely, so y equals k over x. Y is 0.1 when x is 0.5, so I have to multiply both sides by 0.5. 0.1 times 0.5 is 0.05. So that's it. Y is equal to 0.05 over x. Okay. Again, once you identify what to do with that, that gives you the formula, basically, right? And you just kind of run with it. All right, so the last thing I want to talk about is called combined variation. And here you just have to watch the words. This is where they actually do a little bit of direct variation, a little bit of inverse variation, and they just kind of mix it all together. So instead of giving you some kind of formula here, you just read it in the problem. So let me write it. Find an equation of variation for the given situation. Y varies directly, as, that's a keyword, the square of x. The square of x. Okay, we'll talk about that in a second. And y equals 6 when x equals 3. Okay, y varies directly. Y equals k times x. Except this time, it's not x. It's the square of x. X squared. All right, that's all it means. X squared. All right, let's plug it in. So 6 is equal to k times 3 squared. 3 squared is 9, so this is 6 equals 9k. Divide both sides by 9. I get 6 over 9, which is 2/3. So y equals 2/3 x, don't forget the squared, right? X squared. Okay, don't let the words confuse you, right? The square of x. Okay, so we had to throw in an exponent. Last example. Find the equation of variation for the given situation. Y varies, jointly, there's a new one, as x and z, and inversely as w and y equals 3 over 2 when x equals 2, z equals 3, and w equals 4. All right, let's unpack that. A lot going on here. It's actually not a lot. It's not a lot, because you can read this one piece at a time. Y varies in jointly as x and z. Okay, so think about directly, right? Jointly is basically just like directly. Okay, jointly just means that k is going to multiply times both of those. If it were going to say divided by, it would have said inversely by x and z, right? So, all right, y equals variation constant times x times z. That's the jointly part, right? Those are together. And inversely as W. Okay, so there we go. We have our formula here. Okay, so again, don't let jointly confuse you. Jointly just means just do the same thing as you normally would with directly, just put them together. Okay, and then let's plug everything in. So that's going to be 3 over 2 is equal to K, don't know what that is, times 2 times 3 over 4. 2 and 4, that's a half. So 3 over 2 is equal to K times 3 over 2K. If I multiply both sides by 2 over 3, right, to get rid of that, I get 1. K is 1. So Y is equal to 1 xz over W. Okay, that's as complicated as these get. So that's section 2.6. That's the end of chapter 2.